K.
It's C.
It's K.
I'm telling you it's C.
I'm telling you it's K.
I googled it just now, it's definitely C.
Well, so did I. Just afterwards, I used my iPad, googled it, it's K.
Let's write it down. At the
Alright,
same
write it
time, I'm going
down.
to show you.
I will show you.
So
It is K
R
R
A
A
F
F
T.
T.
Craft. Art and craft. You know it.
It's craft. They took over Cadbury's and ruined United Kingdom and...
I see what's happened.
I think I do as well.
It's quite obvious.
Obviously, it's draft.
It's draft. We have a draft to hand in to biology next
week.
Friday.
Yeah. Should do that.
I've done most of it.
I've
Let's
done
just make
most
sure
of
we
it.
do it.
Yeah, sort that out.
Sorry about the argument.
Yeah, so you got, put the K and KC stuff behind us. I'm sorry about the things I said about your mum.
I'm sorry about the things I said about your cat.
Okay. So with that behind us, we should get on with the
KC.
Yeah.
Okay.
Absolutely. So K, that's the rate constant.
And KC, that's the equilibrium
We
constant.
spoke about them both before in previous videos. I'm going to talk about what affects them.
Yep. So first we're going to focus on KC before bringing them together.
Yeah.
So firstly we need to know what KC really is to understand what's going to affect it.
So it's an equilibrium constant, so we have stuff in equilibrium. And as a constant, it sort of shows how it's affecting this. So let's first say, what happens if KC is 1?
Well, if KC, the equilibrium constant, is equal to 1, then that means the position of equilibrium is dead in the centre. I know you don't express it like that, but it's dead in the centre.
Yeah.
Exactly the same amount of products and reactants are being made at the same time.
Precisely. So then if KC was greater than 1, instead it favours the products, more products than reactants being formed in your equilibrium, and that's generally what you want.
Generally want more products. And in the book they use this symbol.
They do a sort of a double crocodile.
Yep, and I think it means KC is well greater than, and not even a shred of doubt in it, bruv, than 1, is what I think it means.
I think that's right. What he said in my voice, but not quite sure from Scunthorpe way, anyway. It's a bit of a scary place.
Very scary.
I'm scared.
So it doesn't mean less than or equal to 1, because when it's equal to 1, that's not right, because we know what equal to 1 means.
So then, if it's less than 1,
And again it uses the double.
then it favours the reactants, and more reactants are formed, and that's generally what you do not want. So now, factors.
Yes. So the only factor actually that affects KC
It's temperature, that's
is
it.
temperature.
Chemistry is about to hot up.
Or cool down.
Or cool down, whenever. So let's start with an endothermic reaction.
So that's when it's a plus at the other side. The overall temperature overall is a plus thingy.
Yeah, so it's positive V and, endothermic.
Endothermic reaction, whatever it may be.
So, what happens if it gets hotter?
Well, if it gets hotter, you know how the position of equilibrium changes from your AS chemistry.
Yeah, just the AS principle.
It's actually KC that dictates the position of equilibrium, so KC goes in the same direction.
It does. If you remember back to AS chemistry, in an endothermic reaction, you can sort of imagine the heat being at this end.
I think that's a good way to think about it. So if you're increasing the heat, is that what you said? Increase it?
I am, yeah.
If you increase the heat, you're increasing this side essentially.
Yeah, so we'll try to
balance
move away.
that. Yeah, it's going to favour this side and go that way. KC is going to increase.
Yeah, and if you decrease it, it will go the other way of endothermic reactions. Then we have exothermic reactions.
Yep. So you can either do another reaction, or you can think about it as, because this is reversible, this way is endothermic, this way must be exothermic.
Yeah, essentially heat on the other side.
Whatever that value is, that will have an actual value. The negative exact value would be this direction. So if you cool it down, take away the heat, it's going to move in the opposite direction. And that's how you can think about it. Or you can just draw another reaction, as it often is a different reaction.
Yeah. So that's temperature. Now other factors affect KC. We have catalysts.
They don't do anything. Because KC is related to equilibrium, if you put in a catalyst, it speeds up both the products and the reactants at the same rate, so it doesn't affect the position.
And the concentration and the pressures. It affects the rate quite quickly, but then equilibrium is just when it reaches equilibrium.
So if you increase the concentration, then it's no longer in equilibrium. So KC doesn't apply. So it will balance itself out over time, and eventually
when it
will
gets
go
there,
back. So
then
that's
KC
when
applies.
KC is applied. Yeah.
Then we have K. And K things are affected by.
Yes. Now, what we've got to think about is what the K and what the KC are really representing in an overall equation.
So, as Wayne said, KC only really applies when you reach equilibrium. But K is all about the rate of your entire reaction. Now we know if we increase temperature, things move faster, there's more chance of successful addition, so reaction speed will increase, so our rate, our K, will increase.
Yep. It's dictated in the book as how fast, and this is how far. Now, this will become clearer in a minute.
Yeah. So, what we want as the highest rate and the highest KC possible. Remember, a higher KC will mean more products are produced.
So that's the same as saying, what's the same as saying? What's the word?
High
What's the
yield?
word? Yield, thank you,
Yeah.
yield. In industry, you're going to want a greater yield, as much of a yield as you can possibly get. But as you increase KC, K will decrease, the rate will decrease. So if this is very big, you're having a very large yield, if this is very, very big, then the rate will be very, very slow. And that's not admirable. You can get a lot, but slowly.
So you have to sort of form a compromise, because the same thing happens the other way. If your rate's really high, often your KC will be really, really low.
And you don't want that either.
So you have to form a compromise between your two reactions. It's in an endothermic. If you had a really, really high temperature and you have a high KC and a high rate, so that's good. But in exothermic, you can reach points which are bad.
So the basic idea is that you want to reach a compromise to get maximum yield and rate. And then they might ask you to bring in atom economy from your AS as well.
Yeah.
Which means only one product, or if you get more than one product, using both.
Mm-hmm.
And that's pretty much it.
That is pretty much it. So now we've had K and KC, I think we should have KFC?
Yeah,
Alright.
absolutely.
Okay, so what's happening now is Wayne misspelled yield in the video. So I've taught him how to spell yield, and he's writing lines, and he's not allowed to have a KFC until he knows how to spell yield. How do you spell yield, Wayne?
Y-E-F-I-E, I'm sorry. Oh my god, I'm going to write a double whiteboard now.
Oh no. I really want those Kentucky Fried Nuggets, you know.